Hey guys, welcome back to my channel. Today we're going to do intersecting secant and chord theorem, which is a part of circle theorems. If you're someone who's struggling with circle theorems, please check out the link above because I've already added to the playlist for IGCSE Edexcel Maths A exam questions. In this playlist, you will see questions from 2018 to 2025. We're discussing different level of questions for each topic, and this will greatly help you in your exam prep. So let's start with this one. It says PTR and QTS are chords of a circle. PT is 3y minus 5, QT is y plus 3, RT is 4x, and ST is x plus 2. Find an expression for y in terms of x. So when we have the intersecting chord theorem, which is this case, what we do is, if I call this A, if I call this B, and C and D, I'm going to multiply A with B, and that's going to be equal to C times D. This is your intersecting chord theorem. The same line is divided into two parts. So the two parts of the same line get multiplied and is equal to the product of the two parts from the other line. Based on that, it's going to be 3y minus 5 times 4x. And then y plus 3 times x plus 2. This is our initial equation. Now we're going to rearrange it to find an expression for y in terms of x. So let's expand the brackets first. 12xy minus 20x equals to xy plus 2y plus 3x plus 6. Collect the terms with y on one side. So 12xy minus xy minus 2y over here. 3x plus 20x plus 6 over here. 12xy minus xy is 11xy. 2y remains as it is. 3x plus 20x is 23x plus 6. Take y common because we have to find expression for y in terms of x. Now we just have one y. Take the 11x to the other side. So 23x plus 6 divided by 11x minus 2 is your expression for y in terms of x. Main thing you need to know is this, that for the same chord, it's divided into two parts. So the product of those two parts is equal to the product of the two parts for the other chord. That is your intersecting chord theorem. Now we have intersecting secant theorem. So for the intersecting secant theorem, the rule is different. For this, what we do is this. The entire line AP is B, and then the part of the line that's outside the circle, that's A. Same with the other one. The entire one is going to be C, is going to be D, and the part that's outside, that is C. So over here, what we're going to do is we're going to multiply A with B equals to C times D, the same formula as we did previously, but now A, B, and C, D are different. A is the part of the secant that's outside the circle, and then you times it by the entire secant length. C is the part of the secant that's outside the circle, and you times it by the entire secant length. So it's going to be 14 times 16 plus 14 equals to 12 times DC plus 12. So the entire secant multiplied by the part that's outside the circle. So 16 plus 14 is going to be 30. And then we do 30 times 14, which is 420. Expand this, 12 times DC is 12 DC plus 144. 420 minus 144 equals to 12 DC. 276. And then we divide 276 by 12, which is going to give us 23. So 23 centimeters is the length of DC. So once again, for the secant, you multiply the entire secant with the part of the secant that's outside the circle, and then put it equal to the other secant being multiplied to the part of the secant that's outside the circle. So that's how you differentiate between the intersecting chord theorem and intersecting secant theorem. Then over here it says AEC and BED are chords of a circle. AE is x plus 5, BE is x, CE is 5x minus 12, and DE is x plus 12. Angle DAE is given as 48. We need to work out the size of angle ADE, this one. So first, let's use the intersecting chord theorem to figure out the value of x, because without that, we can't find the angle. So x plus 5 times 5x minus 12, two parts of the same chord being multiplied equal to the same for the other chord. So x times x plus 12. Expand the bracket. 5x squared minus 12x plus 25x minus 60 equals to x squared plus 12x. Bring all of the terms on one side. 5x squared minus x squared minus 12x plus 25x is 13x. So 13x minus 12x minus 60 equals to 0. That's 4x squared plus x minus 60. That's your quadratic equation. Now we need to factorize this to find the value of x. So to factorize this quadratic equation, if we times 60 by 4, that's 240. So the factors of 40, which when added or subtracted give us 1, that's 15 and 16. So we replace x with plus 16x minus 15x, and then everything else comes as it is. So for this, you just need to know factorization of a quadratic equation. If you want to use the quadratic formula, you can use that. If you want to use splitting the middle term, you can use that. Then you factor by grouping by splitting the equation into two groups. The first two terms make one group and the last two terms make another group. So the first two terms, we have 4x common. So x plus 4 over here. And the last two terms, we have negative 15 common. So that's x plus 4 again over here. So x plus 4 is common between 4x minus 15. So one value of x is negative 4 and the other is coming out as 15 divided by 4, which is equal to 3.75. Obviously, we can't take the negative value, so it's going to be 3.75. So this is 3.75. This is going to be 3.75 plus 5, which is 8.75. And this one is going to be 5 times 3.7, 6.75. And this one is 3.75 plus 12, which is 15.75. So we have all of the lengths now. We have to find angle ADE. So if you notice, we have one complete set of angle and length now, which means we can use this and sine rule to figure out angle D, because we already have the length, which is opposite to angle D, that's 8.75. So just directly use sine rule and we'll have angle D. So let's do that. So 15.75 divided by sine of 48 equals to 8.75 divided by sine of angle D. Sine of angle D equals to 8.75 times sine 48 divided by 15.75, which is going to give us 0.412858. Then we take sine inverse of that. Which equals 24.4 degrees correct to 1 decimal place. This is your angle D. Then this one, it says APB and CPD are chords of a circle. AP is 9 centimeters, PB is 6, and CP is 8. Calculate the length of PD. So now compared to the last one, this one is quite simpler, even though the formula is still the same, but the values are like more basic because there are no expressions. They've given us numerical values. So 8 times PD equals to 6 times 9. PD is going to be 6 times 9 divided by 8, which is going to give us 6.75. So 6.75 centimeters is the length of PD. And it says the points B, C, Y, and X lie on a circle. A, X, Y, and A, B, C are straight lines. AX equals to 12 centimeters, XY is X centimeters, AB is X, and BC is 4. Show that X squared minus 8X minus 144 equals to 0. So it's going to be 12 plus X times 12 equals to X plus 4 times X. The entire secant multiplied with the part of the secant that's outside the circle. So that's 144 plus 12x equals to x squared plus 4x. Bring everything on one side. So x squared plus 4x minus 12x minus 144. And that is x squared minus 8x minus 144 equals to 0 as given the question. Now it says find the length of AC. So to find the length of AC, obviously we need the value of x. So let's factorize this equation. So to factorize this quadratic equation, we're going to use the quadratic formula. X equals to negative minus 8 plus minus root of negative 8 square minus 4 times 1 times negative 144 divided by 2 times 1. That's going to give us 8 plus minus 25.298 divided by 2. So one value of x is going to be 8 plus 25.298 divided by 2, which is 16.6. And the other one is going to be 8 minus 25.28 divided by 2, which is negative 8.64. Obviously, we can't take the negative value, so it's going to be the positive one. So AC is going to be 16.6 plus 4, which is equal to 20.6. That's the value of AC correct to 3 significant figures. A, D, B, and E are points on a circle with center O. AF, BC, OEC, and OFD are straight lines. AF equals to 7 centimeters, FB is 4 centimeters, BC is 5, FD is 2, and CE is X. We have to work out the value of X, show you're working clearly. As you can see, O is the center, which means OE and OD are basically the radius. So let me call this R. And since this part is 2, that means this is going to be R minus 2 because the entire OD is R. So we have 2 chords and then we have 2 secants as well. For the chords, it's going to be AF times FB equals to OF times FD. So AF is 7 times 4 equals to R minus 2 times 2. So using this equation, we can figure out the value of R first, which is the radius. So 28 divided by 2 equals to R minus 2. 14 equals to R minus 2, and that is going to be 60. So R is 60. Now using the secant theorem, we can figure out the value of X. So secant, let me divide this so that there's no confusion. So for the secant theorem, our secants are this one and this one. So that's going to be 7 plus 5 plus 4 AC times BC equals to OC times EC. So AC is going to be 7 plus 4 plus 5, which is 16. BC is 5 equals to OC, which is 16 plus X times X. So 16 times 5 is 80. 80 equals to 16x plus x squared. Bring everything on one side. So x squared plus 16x minus 80. Now we have to factorize this quadratic equation to figure out the value of x. So we can do 0 equals to x squared plus 20x minus 4x minus 80. So x common between the first two terms, so x plus 20, and negative 4 common in the last two terms, that's again x plus 20 in the bracket. So x plus 20 is common, x minus 4 comes in the other bracket. So the value of x is going to be 4 because negative 20 cannot be the length. So x equals to 4. And with that, we're done with the questions for intersecting secant and chord theorem. You just need to know how to distinguish between the two. And if you understand that, then the question is quite simple. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, like and subscribe, share this video with your friends, and make sure to check out the other videos in the playlist because they're going to help you with the exam prep.